Good evening, one and all. Sorry for the delay due to some technical issue. Now it is of great privilege for me, Dr. Neeta Repade from Department of Electronics and Telecommunication Engineering YCC, Nagpur, and co-coordinator of this two-week blended AICTE Training and Learning Academy sponsored faculty development program on remote sensing applications with machine learning RSAML 2023. On behalf of organizing team RSAML 2023 to welcome you all here. Today, we will be listening to great learned experts from the field of remote sensing and will explore its importance and applications using image processing machine learning in the real world. I, Dr. Neeta Repade, ATAL FDP co-coordinator, present before you this first session of the ATAL FDP to enrich you will with the zeal of experiences from well-known academicians and professionals from remote sensing field. I extend my warmest welcome to each and everyone invited here on a very auspicious moment in this spectacular evening on behalf of organizing team RSAML 2023. Without wasting much time, now I would like to call upon Dr. M.S. Narlavar, Head of the Department of ETC, YCCE, to welcome one and all present here. Over to you, sir.
Thank you, ma'am. Dignitaries in the inaugural function, Dr. S.V. Balamwar, sir, Scientist, MRSAC Nagpur, Coordinator of FDP, Dr. Mushrif, sir, Nimbarte, ma'am, Belsare, ma'am, my departmental colleagues, and my dear participant friends. A warm good evening to one and all. I am extremely delighted to welcome you all in the Department of Electronics and Telecommunication Engineering for 2-week ATAL FDP on remote sensing applications with machine learning. Our institute has established in 1984 and got autonomous in 2010. YCC has recently been awarded with A++ grade by NAC. All the branches in YCC are NBA accredited. Department of Electronics and Telecommunication Engineering of YCC started in 2001 with an intake capacity of 60, which now increased to 180. Some good features of the department includes collaborative projects with Harvard University USA, SID Indonesia, ISRO, NIRI, MRSAC, excellent placements, highly qualified and experienced faculty members, and good infrastructure. Our department has fetched grants of around more than 1 crore rupees from various government funding agencies under research and non-research categories. More than 50% faculty members of our department are PhD qualified, and remaining faculty members are pursuing their PhD. There are very good publications, patents, and copyrights to the credit of faculty members of our department. We are carrying out major research work in the area of digital and uh, signal and image processing, and wireless communication and antenna design. For our FDP, we have received overwhelming response from different corners of our country and abroad as well. Renowned experts from prestigious institutions will deliver their lectures in our FDP. I am very sure that you would have wonderful learning for next 2 weeks. I wish you all very happy learning and pleasant stay in the campus. Thank you. Thank you all. Over to you, Nita ma'am.
Yeah, thank you, Narlar sir. Further, I would like to invite the coordinator of this two-week ATAL FDP, Dr. M. Mushrif, for his opening remarks on FDP. Over to you, sir.
Hello, am I audible?
Yes, sir.
So, very good evening to one and all. Today's expert, Dr. S.V. Balamwar, sir, scientist, MRSAC Nagpur. Our HOD, Dr. M.S. Narlawar, my co-coordinators, Dr. A.D. Bilsare, Dr. N.D. Raipade, my committee members, my colleagues, dear participants, and dear students who have joined this program. I welcome you all to this AICTE sponsored ATAL FDP on remote sensing applications with machine learning. This FDP is a 2 week FDP. Uh, it will be conducted during 30th Jan to 10th February. First week will be uh, uh, in virtual mode, and it will be conducted from 7 p.m. to 9:30 p.m. And in the first week, uh, mainly the concepts, theory, some research avenues, emerging trends will be covered by our experts. And in the second week, uh, it is second in second week the FDP will be conducted in offline mode, where the participants will be able to gain knowledge through practicals labs. uh, then there is one visit to MRSAC and so on. Uh, the This is a continuous comprehensive. There will be continuous comprehensive assessment of attendees. So overall, you need to score say 70% to receive certificate, and get 90% or more to get distinction. So there will be a continuous assessment of the participants throughout this FDP through various quizzes and other modes. Uh, and for this FDP, we have invited eminent speakers from IIT Bombay, IIT Nagpur, other premier institutions from the country. And we have also invited eminent scientists from NRSAP Nagpur, NRSC Nagpur for delivering their expert talks, and as well as conduct practical sessions. Uh, and as I told you, there will be one day visit to MRSAT. So thanks to MRSAT for allowing us to have a visit at MRSAT. Uh, Now already we are late by some 15-20 minutes, so I won't take much time. Uh, I'm sure that all the participants will be immensely benefited uh, from the knowledge shared by our speakers. So I wish all the participants very best for the FDP. Thank you.
Thank you, Mushrif sir. Now, today we have with us a learned expert from a remote sensing area, Dr. S.V. Balamwar sir from MRSAC Nagpur, as our first speaker. Balamwar sir did PhD in investigations of dielectric properties and related thermodynamics of some polar liquids at microwave frequency from RTM University of Nagpur. He is working as a senior scientist in Maharashtra Remote Sensing Application Center, Department of Planning, Government of Maharashtra, Nagpur from last 21 years. He was completed training on advanced digital and photogrammetric processes in Netherlands, Europe. His specialization in is in geographical information systems, image processing, photogrammetry software, GPS, and AutoCAD. He has published more than 45 international and national research papers. He visited various geospatial industries across the globe. He has also received various awards at state and central level, including the AGI India Awards 2022 for prestigious project of Mahabhumi, which will going to transform various government schemes and infrastructure development programs in the state of Maharashtra. Now I request Dr. S.V. Balamwar sir to take over the charge and light up all the listeners with your expertise. Over to you, sir. Balamwar sir.
Thank you, madam. Thank you for very descriptive introduction of mine. Welcome you all in this faculty development program because such program should bridge the gap between our industries requirement and academics. So the academicians should know the basic of the subjects and its application, which will be the very essential requirement of the industries. And there is a big gap in industry as well as in academics. So such type of programs will help in bridging the gap between the application people as well as the academic. So nowadays, GIS means Geographical Information System and remote
Uh,
sensing. Hello.
Excuse me, sir. Please share your PPT.
Yeah, I'm
It
sharing
is
it
not.
also. Yes.
Yeah.
So nowadays, GIS and remote sensing is essentially in government decision support system. There is one prestigious means dream project as a PM Gati Shakti, which will help the government to do e-governance and take appropriate decisions in the field of any development as well as the means development activities in the country. So in PM Gati Shakti program, so there are various, what you can say, the layers means various schemes are available to work on it, so that in suppose you wanted to construct some dam, how fast it can be constructed and what will be the scientific input required, that will be fulfilled using such a portal from various departments in a single platform. So this will be a single window system where all the database will be available for the development of the development as well as decision support to the administrator or decision makers. So before going to this, we such means firstly introduce some basic part of what remote sensing actually does and what is meant by remote sensing. So we'll do some introduction about it. So remote sensing means what? What are the basic elements involved in the remote sensing that we'll see? So remote sensing is nothing but a simple means from basic. I will explain from basic to the digital image processing in future. So reading a book is a simple example of remote sensing. Seeing an object, taking a photograph. So this is a basic type of remote sensing everybody knows. So taking the advantage of these, we are going to extract very useful information in the form of data. So this remote sensing requires some components, but this is called the source of light, media, target, sensor. So it depends again on what type of remote sensing you are doing, whether it is optical remote sensing, whether it is microwave remote sensing, whether it is thermal remote sensing, or communication is also one part of remote sensing. So in practical, remote sensing target is Earth, source is the sun, and sensors are the scanner or the cameras placed on the satellite, airplanes, or balloon at any type. So depending upon the scanning of the Earth, the remote sensing is divided in different platforms like satellite remote sensing, like airborne remote sensing, balloon remote sensing or terrestrial remote sensing. So whether your camera or scanner is there, depending upon that, your type of remote sensing can be classified. So in remote sensing, you require first, the prime requirement is the energy source, the radiation, and atmosphere, the interaction of atmosphere with your electromagnetic radiations, the interaction with the target. So again, that are means interaction depends upon the what are the molecules present on the atmosphere, what is the how is the scattering can occur. So on that basic parameters, this remote sensing data is dependent. So after interaction with target, the sensor will take the recording of that interaction with the target in the sensor, and that information is transmitted to the antennas and received in the data storage devices after some processing. And this process and received data can be interpreted or analyzed in the lab using various type of softwares, various type of software, various types of methods, and for various applications of that data can be done. So we know the sun radiates energy in the form of electromagnetic radiation in various electromagnetic regions. So in remote sensing, you can use the optical band or visible band of the electromagnetic spectrum, microwave band of the electromagnetic spectrum, or ultraviolet radio frequency bands, or thermal band of the electromagnetic spectrum as well. So we know in visible, mostly in optical remote sensing, what we are analyzing in our applications. So most of the time we use the optical data for it. So we know because whatever we are visualizing, that can be interpreted by our brain and can extract the proper information. Similar type of information can be extracted using our machine learning program or by using some signature file creation, and automatically or digitally we can analyze how the human being can be differentiate different objects by looking at it. The same process we can model using the software or using the various type of algorithms to how to separate out the various objects in the given type of data or image. So in visible range, there are various interaction with the objects, and various objects can reflect back or emit different type of the wavelength or characteristics. That characteristic can be used to identify that particular object in the interpretation methods or in segmentation method. So we know in visually simple photograph you will click, that also gives some information whether you can have the vegetation cover, the water bodies, or some barren land like that. But that can be seen in visible band only. But in satellite, we have the extended vision. We can go up to the infrared region. So whatever you are seeing in visible region, will get more extended vision. So you can see more of the characteristic of the object that our normal eye cannot be detected. So this the advantage of this remote sensing is it got the extended vision, so it can extract more information. It can go in an inaccessible area, or it can have a large area coverage at a single time. So it can be a regional view, a local view, or a global view that satellite data can have. So while but are different obstacles also while interpreting this data, because once in the case of this satellite data, the satellite data when we are talking about, so there are different layers in the atmosphere are exosphere, thermosphere, mesosphere, stratosphere, and troposphere. All these various layers are there around our Earth. So once the electromagnetic radiation received on targeted our object, so there will be some energy reflected back towards the satellite. So while means this energy is capturing back by the sensor, in between there are various obstacles are there, because it has to pass through all these 4 or 5 layers. So the what you can say their strength, or there may be some noise in the reflection what is back scanning by the sensor on the satellite. So how to minimize this? So this is a different science behind is there, that is called the atmospheric corrections, the radiometric corrections. So these, after doing all these type of corrections, we can analyze or we can interpret properly what is what and what is where to the remote sensing techniques. So there are different on the different height, different parameters are there, and how it is behaving. That with again there may be a direct relationship between the temperature, humidity, and the height of the object from the Earth. So all these will matter while interpreting the data. So there are different phenomena are there while taking this reflection or the reflected energy back to the sensor. So scattering occurs when particles are large gas molecules present in the atmosphere interact with and cause the electromagnetic radiation to be redirected from its original path. So there may be a confusion between. So this confusion or this noise can be removed by different techniques. There are different algorithms nowadays because of various pollution also some scattering is occurring. That also can be by program you can reduce or you can minimize that error in the data. So depending upon the particle size, the relay scattering occurs when particles are very small compared to the wavelength of the radiation. So this could be because these are the 3 cases that can be happen, because when the particle is very small compared to the wavelength, relay scattering will occur. How to correct this relay scattering? There is a different methods are available. So you have to take care of this type of various scattering around the object, and it is taking it back by the sensor. So these, in this case, the particles such as small speck or dust or nitrogen oxygen molecule that can cause the relay scattering. The noise scattering occurs when the particles are just about the same size of the length. These such type of noise scattering will occur. So this can also be minimized in radiometric corrections in the data. Okay. So this occurs when the particles, non-selective scattering occurs when the particles are much larger than the wavelength of the radiation. So there are also different, what you can say, the phenomena are occurring while taking the information from the satellite of the objects present on the Earth. So there are some absorptions in the mechanism is also there in the atmosphere because of ozone layer, carbon dioxide, and water vapors. So there are electromagnetic radiation interact with this atmosphere, and depending upon the incident angle or incident energy, absorption energy, and transmission, reflection. So you know the black body concept of the objects or energy. So all three will work in conjunction with each other. So there will be the interaction with the target of the electromagnetic radiation, and there may be a specular reflection or diffuse reflection character. So these type of noise you must consider while interpreting or classifying your data. So our means in infrared region, what will be the reflection? In red band, what will be the reflection? In green band means up the wavelength, what will be the reflection? So there are different reflection you can get in different wavelength region. So that can be plot reflectance versus wavelength, how the vegetation can do behave in a particular spectrum, and water will behave. So you have to take all these basic things to clarify our and to go to design our algorithm of classification or segmentation in the using the satellite remote sensing or unmanned vehicle data. So there are these are the different spectral responses of different objects like iron oxide, how it behaves in different region of the spectra, how the dry vegetation is, how the healthy vegetation is, how water is behaving in various. So this the basic we should know before going to classify or to interpret the data. So depending upon, we already told, depending upon the type of we kind of platform, the various type of remote sensings are known. But what is called terrestrial remote sensing, using your object from the photograph from the ground only. Aerial photography you can take, and you can use satellite remote sensing in space. So there are different satellites, and depending upon their orbits and slot, different types of satellites are available. So there are basically two types of satellites are there. One is a geostationary satellites, now also called the communication satellite, like INSAT, series of Indian satellites. Some synchronous satellites are generally the remote sensing satellites, which we can use for various object identification or various crop applications, flood damage assessment, all these type of applications we can use using satellite remote sensing data. So suppose if we want to study in Maharashtra, so Indian remote sensing satellite is famous in India. For Maharashtra, there are total 32 scenes the data is required to cover the entire Maharashtra, because it have a definite path and roads to cover the entire state. So this is a satellite called Indian Remote Sensing Satellite P6 series. Sensor is listed linear imaging selfie. I mean, third three is the sensor name of that particular satellite. So such type of satellites you have to choose, and what are their SWAT, and how much area one scene can be covered. Depending upon that, we have to choose your satellite data for various applications. Suppose I wanted to study only the Mumbai district, so I will analyze that particular path and route data, not entire satellite data. So selection of this data is also very important while doing your study in different level. So we know in digital there is digital image processing. Whatever data it is seen, it is that one shot that is called one pixel, that picture element, because this is data in the form of raster. So every picture element pixel is having the is value of reflection back from that particular object, depending upon its characteristics, whether it is coming from water body In water bodies, mostly what happens, the radiation absorbs the water body and very few reflected energy will get back towards the sensor. But in vegetation, some red band or in green band, there is more reflection. In infrared band, there is very high reflection for vegetation. So every area scanned by the sensor is one picture element, that is called pixel. So in single band, the particular pixel have particular value, that is suppose 170 in a particular band of green. Similarly, in the red band, there may be 190 value of that pixel. In infrared, it may be 320 if it is vegetation. So, such that in different bands, you will get such a different type of pixel elements. So, combining all these pixel elements, you will get different scenario of different objects when you will go or classify or by analyzing it digitally using various softwares or using different algorithms. So, yes, therefore, we should know what will be the characteristic of what in particular electromagnetic band. Depending upon it only, we can able to analyze the data. So there are different aspects of satellite data as well. So if you wanted to know the synaptic view or regional view of any particular area, so you require very coarse or low resolution satellite data. So it may be low spatial resolution. So you will get the synaptic area. So major feature like river, where are the agriculture lands are there. So such type of data is of low volume. So analysis of the data, suppose I wanted to analyze entire Maharashtra, so in a single shot. So I will take only small scale data, coarse resolution data to analyze. I will then, I can classify the entire scenario of Maharashtra into major four groups only. So I will classify it as agricultural land, water bodies, forest, like that. Only I can know such type of 4 or 5 classes, that is called L1 classification of the data we can do. But if you want very micro level of information requirement, then there may be a large scale data, which is called very fine or high resolution satellite data. But it will, we can collect in small pockets, so we can have a fine feature, and such type of data are very voluminous data to analyze it. So it takes more time to do the analysis for it. So in remote sensing, there are different type of resolutions are available. There are spectral resolutions, means number of bands the particular data is having, like whether the data is 4 band, means different bands are there, 6 band, 7 band, 8 band, how fine refinement in the spectral bands or discreteness in the band, accordingly that spectral resolution data can be captured. The temporal resolution, you know, temporal resolution is nothing but the revisit capability to the same location. Suppose in Nagpur, if I wanted to take change detection process of Nagpur city in last 20 years. So I will first choose the data of 2002, and after 5 years, 2007, after again 10 years, 2010, likewise, I will collect the data temporarily of the same location, so that I can have the change detection analysis of the particular area. So it is a revisit capability, time between 2 successive visits, important for study and data selection. So this is called temporal resolution. And radiometric resolution is nothing but the ability to discriminate very slight differences in energy. Means it may be 4 bit, it may be 8 bit, it may be 16 bit. How discretely the data can be discriminated. So this bit of the data, the information content is nothing but the radiometric resolution. So more the radiometric resolution means more fine-tune the image is, more information we can extract from the more radiometric resolution data. So radiometric resolution is low, then you have fewer number of classes, but if it will be high, then it will get the more descriptive or level 2, level 3 classification or detailed information about of the object, whether the color is what is exact volume is there. So that type of analysis can be done. Number of what are the different species are available. So such type of analysis with what are the different crops are available. Even you can intercrop scenario, different type of crops can be identified using a very high radiometric resolution type of data. So there are different methods of scanning of the satellite. So there are mainly two types of spectral scannings are available. One is called across patch scanning, because satellite will take the means view in across of the path of the satellite or movement of the satellite, where in a long track it will run and will collect the data towards the movement of the satellite. So there are the different instantaneous field of view, cell size, path, detector, all such type of terminologies are here in across track scanning. And whatever your full view is called the swath of the satellite. So each instance of the photo is called pixel. So each pixel may be across track scanning and along track scanning. The processing in both the cases are different. So therefore, you have to be very careful while choosing your satellite data, whether it will be in across track scanning or in along track scanning. This type of scanning will affect in geometric corrections of the data. So there may be geometric distortion in imagery, in perspective of the sensor optics, the motion of the scanning system, the motion instability of the platform altitude and velocity, while because of perturbation of the earth, again the terrain rigid on the ground, the curvature and rotation of the earth, all this leads to geometric distortion in the satellite data. So that should be removed in various enhancement process of data correction or geometric corrections of the data. So there are different this data after receiving. There are various ground receiving stations available, and these ground receiving stations should be along the line of sight of the satellite. There are on-board receiving stations are also available in some cases. Tracking your data in the satellite systems to communicate the data storage and data receipt. So there are various ground stations are available, international ground stations to receive the data. In India, there is one ground station, which is in Sadnagar, Hyderabad. Here, all national or international satellite data are available only in this station in India, and there are only two data receiving stations. Now, using very small satellite data, micro satellite data, the directly we can have the data storage devices on board in the satellite. They will collect and will come back. Such type of also system is available nowadays. So there are different stages of data taking data by satellite. There may be data acquisition, data storage, retrieval and interpretation and analysis. So now, how this digital image processing can be done? So what are the different elements in this digital image processing? So we know satellite remote sensing records images in multiple spectral bands, while green band, red band, infrared band, blue band. So to combine all these bands to prepare the false color composite, because the whatever vegetation you are capturing here using infrared band. So whatever green you are looking here is looking red. So it is called false color composite. Actually, naturally, all means trees or crops should look green, but in false color composite, it will look red. It has one special advantage of it to while in means processing the data, whatever natural vegetations are there that can be classified differently, but when it will not use infrared band, so whatever man-made or natural can be classified means the same. So there are various elements of interpretation of the data. They means by visually you can interpret the data by identifying different image elements like tone, texture, pattern of the your objects, shape of the object, size of the object, whether the shadow is there or not, means whether it is heighted building or hills, where are the sides, what are the association. So such type of image elements will help in identifying the signatures or identifying the objects by the human interpreter. So what is meant by tone means relative shades, texture means what, pattern means what, shape, how the shape it is general form or configuration or very systematic shapes are there. So whether it is urban area, whether it is agricultural land, whether where it is a water body or not, whether the linear features are there, whether it is road, canal, or suppose what you can say the express highways and all. So depending upon these size, shadow, site, and association, we can identify the objects by topography, drainage density, drainage pattern, and all will help in identifying various water resources, assets, water resources features. So all this can be identified using various these interpreted elements. So we know uh, how the shape can identify field road, house, football stadium, whether it is cricket stadium, baseball stadium, lawn tennis, like that. So these all can be classified in shape. What are different shapes of the whether it is agricultural land or what, or whether they may be a new layout area. So such type of shapes can be uh, means can be used to identify the target. So whether it is the road is going through a particular hill, so whether there is a tunnel or what, so how to continue it. That tunnel is not visible on the top of the uh, uh, top of the hill. So this can be there may be break in the road. So, but by knowing the continuity of this feature, you can say this road is passing through this area. So such type of means associations or shape or tone, you can identify what is what. So whether it is grapes land or whether it is settlement, what are the different what you can say survey numbers, what are the different crops available in it. So such type of by using tone only you can identify it. So in size, what are the different satellites is given a different type of size of the river is here. So such type of elements will useful in doing what you can say the interpretation of the data. So what is pattern, whether it is residential area, planned residential area, or old residential area, whether it is natural vegetation or plantation. So such type of application can be done using different interpretation elements. Whether the texture is smooth or whether the texture is close, so whether it is mangrove area or whether it is forest area, that can be identified. So using shadows, whether the tall buildings are there, very high hills are there, the cliffs of the hills can be means looking in shadows. So such type of elements can be utilized, whether it is high building or high-rise building or ground buildings or like that. So where are the association, where are the, suppose there is a sea, you are looking, there are boats, so you can identify these are boats or not. So such type of association is also required to interpret the data. The pairing element, whether it is top to top or it is slope areas, that can also be identified. So in map and in satellite data, how the different scenario is there, that can be also identified. For drainage network, the view of watershed, how the watershed can be identified using a particular pattern of drainages, and you can delineate that watershed boundary so that the development in the area can be done by the government agencies. So such type of some elements which will be used to interpret particular data. So whether the erosions are happening there, so whether it is a revenue land or what, whether it is cultivable land, cultivable lands or not. So such type of whether the rocky areas are there. Okay. So uh, in remote sensing data, there are already we know because of detectors, because of earth rotation, there are different what you can say noise are available in the data. So pre-processing of such data is required before interpretation of the satellite data. There may be a de-stripping in the data because one of the detector will not work. So how to come over and will make the data useful. So some drop lines are available or not. So there are different methods to correct this uh, noise in the satellite data. So we require some image enhancement for better visual effects and for what you can say separability of the features of the in the images. So there are various transformation and operation you have to do. So some in on also composite, we can prepare some indices using different bands to get the information about the particular object or the particular thing. So there are various geometric correction methods are available. So you have to put, because your satellite data is in the raw form, it is in the form of rows and columns, how to transform that in a particular geographic area so that there may be, if you wanted to take some development measures, how to go on the ground and how to measure or how to find the area where the particular thing is happening, where should be a canal alignment, where should be a road. So it requires the geometry correction using ground control points from the ground so that that particular satellite data will hit on your geographic location so that you can have various operation on from where your primary school is available, where your sugar factory is there, where is your hospital, where are the nearest police stations. Such type of neighborhood operations you can perform if you uh, can do the geometry corrections of your satellite data correctly. So you can have image registration so that it will be easy to do. Otherwise, you can conduct the ground control point and then can correct your image geometrically. So there are different means on raw image you cannot do performance like area measurement, dimension measurement like that. But once you geometrically rectify it, that rectify after rectification, it can be used as what you can say, while for the calculation of area, calculation of length, or field alignment, or anything with operations operators you can do and analyze. So you know what is image classification. Grouping the image into, suppose if your data is having three different bands are available with you in green, red, and blue band, the data is available. So how to classify and get extract the information out of it. So statistically, what you can say, you can group that entire data into, suppose, 10 to 15 classes. So depending upon their characteristics of the pixels, you can segment your image in suppose 3 to 4 classes. So whether that pixels are having water bodies, whether it is uh, agriculture land, or whether it is rock. So only grouping using statistics is different, and by giving some signatures and telling your system so what particular pixels are having which property, so you can do your supervised algorithms, and you can have the classification as per your signature file, or as per your class names. So once this data is supervised, means uh, classified, you can use it as for crop monitoring, or even you can have some of your village maps can overlaid on the data, so that which particular parcel is having which type of crop that can be identified. So this georeference village maps can be overlaid on this satellite data, so that particular survey number is having what type of crops are available. Suppose if flood occurs and particular survey number is got damaged, so how much damage that can be happen to the particular survey number, or which type of crop is got damaged, that can be also quantified using such type of satellite data with your geometrically corrected and with ground control points, and the particular correct classification of the data. You can even know how much hectare of area can be affected, or how much crop acreage or crop yield is there. Such type of operations you can do using this data. So this data is of Buldana district with a Taluka boundary overlaid on it of different season, October, November, December. How the water bodies are getting depleting because we are going towards December from October, or whether vegetation is occurring, which type of crops are there. Such type of analysis you can have. So there are different series of data are available in Mandara district. This is Hingoli, and even using the satellite data, which taluka is having a sugarcane crop and how much hectare area that crop is available, whether the forest and what other different crops are available. Such type of analysis we can do using such type of uh, data analysis. So suppose there is a hailstorm in particular area, and we know the hailstorm is occurred in a particular zone only, in particular line only. See how this data in particular area is washed out here due to hailstorm in 6th June in 2002 study. So this particular area is got affected, not other area. So how much parcel numbers are affected? So that can be studied using this type of satellite data. So there are different methods of from data processing to data analysis. So this complete cycle we have to perform using this type of remote sensing data digitally by using digital image processing. So, so there are different information extraction from remote sensing images on water resources, agriculture and soil, forestry and ecology, geology and geomorphology. coastal processes and marine science, human settlement, natural resources monitoring. These can be very useful application areas of digital image processing using remote sensing data. So, what are the different scenario of water in different type of seasons? So, how that in which month the data, the water is available and how much extent, how the lowest extent, how drought is happening, whether really drought is there or not. So whether how much water spread are there, depending upon this, the drought monitoring also can be done, and the compensation is being made to the affected farmers depending upon this type of analysis. So there is digitalization models can be used to do a 3D perspective for creation of contour and slope map, where even you can identify whether the flow direction is in particular direction or not. That also can be decided. So we can have some soil and water conservation measures we can do using such type of satellite data. So these are whether the contour trenching are being done because of this high slope area, so that this soil and water can be conserved in a particular area of the district. So whether this data can be also used in various uh, drinking water emissions, whether what type of land is there. So the advantage of this study is because it covers the regional survey of various earth features, retentive coverage, data acquisition, that same data can be analyzed different for different purposes and application, amenability of remote sensing data to computer processing. So there are in India there are different satellite vehicles are available which can have the capability of doing various launching of the remote sensing as well as USS satellite. These are the different Indian image system satellites are available in India. So it has the capability of having 1 kilometer to 1 meter. So this is the satellite data of various regions of Pune district. So whether the airport is there or not, what are the means area, different strips are there, whether the airport are there is not, what, how many over bridges are there over the river. So whether where to construct the ROBs and all, this can be done using this type of satellite data. So whether the mines are there, mining activities are going on there or not, that can also can be identified using this. So this is the satellite data view of Lunar Lake, which was created out of hypervelocity meteorite impact on the Earth before 40,000 years old. So there may be the relation between satellite image and ground realities. So depending upon these signatures, we can have the different analysis of the data. So this is we were having natural vegetation covered over it. So this is very beautiful example there because there are water underneath of these vegetations. So this is some not of the plantation because these are different species having different reflections. So we can have temporal changes. Suppose here in particular days there were no plantation, I mean cropland, but here you are looking some crops are present on it. So this is two-color composite and the difference between two-color composite and phosphor composite. Two-color composite have some limitations of identification of the species, while phosphor composites are more information giver. So there are some orange answers, whether which orange answers are healthier and which are poor. That the health of answer also can be identified using this type of satellite data. So there are some examples. So this is all about our remote sensing data. If you wanted to ask any questions, you can please now open for questions. Hello. Hello.
Yes, sir.
Madam, this is now over.
Okay. So participant, any question from your side?
Hello, sir.
Ah,
Sir, I'm Dr. Yogita Chitriyu. I just wanted to know, we have worked with MRSAC. We work on the MRSAC database, but
okay.
these database, are they available open source? Like if there is, means if we not be able to reach out to MRSAC and we want to work solo, then are these database set and their ground tools are available open source?
Yeah, because now new geospatial policy 2021 is that any data having resolution of more than 1 meter is available to anybody. So you can use the database because there is a one portal Bhuvan is there. So from Bhuvan you can download the data of your choice
Okay.
of last 20 years. So that are available there. Even from Google Earth also you can download data from in high resolution data from 2002 onward.
Okay. Thank you, sir.
Any question?
Hello. Sir, you have shown one Maharashtra map. So could you
Yes.
please highlight on the concept of row and path once again, in short?
Yeah. Because yeah, I will go in that site only. But in that particular area what we are looking now, there is a particular satellite is having particular path and rows of it. Okay.
Yeah.
So different satellites have different path and row systems. So because what I've shown is only for one satellite only, that is IRS list 4 list 3 data. So in that case, that pattern row is there, and this pattern row map is available on their site. So whatever that satellite providers are there, they will means give this map to you, so that you can choose any particular area. Even by your nowadays, because of various portals are available, you can put your city name or area name based on that location query also you can get the satellite data part as well.
Okay. Thank you, sir.
Yeah, yeah.
So thank you, sir, for encouraging us with your wonderful session. I assure that many of us are inspired and will take remote sensing as an opportunity for research henceforth. Now I request each one to please switch on the camera for a group photo with the speaker. Please switch on. All the participants, please switch on their camera. So we will take.
Hello, Tripathi, sir.
Yes, madam.
Dear participants, please switch on the camera for a group photo. Yes, I'm taking the photo. Please switch on the camera. Yes, thank you all. Ripada madam, you can carry on, please.
Okay. Now I request you to please accept the token of love from all of us. Thank you once again, Balamba sir. Thank you. Thank you once again. Now I request Professor Kanchan Kamre madam to proceed for the next session. Over to you, madam. Kamre madam.
Thank you, madam. Good evening, one and all. I, Professor Kanchan Kamble, ATAL FDP committee member, present before you the second session of the ATAL FDP to enrich you with the deal of experiences from well-known academicians and professionals from remote sensing fields. Today, we have with us a learned expert from remote sensing area, Dr. Amit Kumar as our speaker. Dr. Amit Kumar Tripathi is a professor in computer engineering at Don Bosco Institute of Technology, University of Mumbai, India. He is the director of Center for Geo AI and Machine Learning at DTI and had been the Dean of Research and Development. He is also an adjunct professor to School of Science, Edith Cowan University, Perth, Australia. He had been visiting researchers and research mentors to smart farming projects at RM University of Technology, Bangkok campus, and Dr. Tripathi had been the secretary to Rashtriya Uच्चतर Shiksha Abhiyan, Government of Maharashtra, India for Higher Studies in Geospatial Technology. He had been chairman to the IEEE Geoscience and Remote Sensing Society, Bombay chapter. He is the executive editor to DDIT Journal of Science and Engineering and guest editor to the NPTI Journal. Advances on Cloud Computing and Internet of Things. He had been editorial board member of IEEE Transactions on Computational Social Systems and Elsewhere Journal of Information Science. He has been the Journal Chair, Program Chair, Track Chair to many IEEE or ACM conferences, symposiums, and has delivered many keynotes for plenary talks. Dr. Tripathi earned PhD from Indian Institute of Technology, Bombay, Mumbai, India, and has been 26 years in software industry, research, and academics, having 140 plus publications previously. He has supervised 5 PhD scholars and 5 R.A. his research domains are of data science, computer vision, remote sensing, embedded systems, and IoT for agriculture and rural development. Dr. Tripathi has been carried out collaborative projects like bilateral PSP or JSP projects between India and China, with UICT and sensor network-based real-time decision support systems for agriculture and environment applications. Technologies for sustainable urban agriculture in smart cities under Australia-India Scientific and Technological Research Program. Geospatial data mining to assess the impact of watershed development at CCA Australia. IoT-based farm monitoring systems in Thailand farming at IS University of Technology, Bangkok, Thailand. Comprehensive Development Plan for Commutation of Tribal Community, Maharashtra. A geospatial model for assessment of agriculture, craft, Vulnerability is
Kanchan madam, please stop it because it's going too much. So let's
okay.
look into that. The
Okay,
work.
thank you, sir.
All right, yeah. Otherwise, it is going too much. Okay. All right.
Okay, so I
Yeah.
request you please take over the chat and write up the listeners with your expert. Please,
Yes,
sir.
yes, yes. So good evening, everybody. I am Dr. Amit Tripathi, right? I have been, though I am in computer science and computer engineering, that's my background, but I have love for agriculture because I am born and brought up in agriculture. And that's what the one, and a lot of projects I have done with electronics and communication side, and which is application to agriculture at the same time also remote sensing and GIS, how this can be applicable to agriculture. That's what there are a couple of projects which I have done, from the East India Australia bilateral part of view, as well as the Japan and India bilateral part of view. There are a couple of international projects which are based upon the agriculture sectors, wherein remote sensing and IoT and sensor network has been used, and some of them I will try to share how I have done and what the actual things are there. And that's what that the technology we require, particularly for the Indian farmers are concerned, or India itself is concerned towards developing towards a developed country, because India fully depend upon the the agriculture, agricultural products are concerned over there. So I will share on my experience in this. So anytime you can stop me to ask a question also, right? So a couple of works which is our consultancy, as well as some of research work also. I will time to time I will share over here, and that's what, right? Because recently I'm working with a consulting firm in Abu Dhabi, where that is all the date form, and that's the Khajur so called, right? That's also different kind of technology we are using, both remote sensing as well as the quadcopter and all things are there. So I'll try to share all such kind of things. Let me share my slide now. 1 minute. I'm just sharing my slide. Is this slide visible to you all? Please let me know.
Not yet, sir. Yeah, now it is visible.
All right. So the topic of is remote sensing for agriculture monitoring and yield assessment. Some of the terms you have to, to aware of that one also, right? So few things I would like to share in that way. But prior to that, let me talk about something like the question comes in picture that how does remote sensing impact different aspects of cultivation and enable so-called the smarter farming decision. That's what the other countries has been doing, like developed countries so-called, but wherein we are a bit of lagging behind, though we are gradually capturing all such kind of things with the technological advancements are concerned. But this the question comes into picture as of now. So so let me talk about few lines on this one, what exactly it means, what exactly it means over there. So when we talk about these kind of things, then one thing that comes in picture is of like when you are posing a question, then obviously comes in remote sensing, right? So let me just briefly I try to say that one. Remote sensing is basically the ability to obtain information about an area or an object without direct or physical contact, and has evolved significantly since those early aerial adventure to today. It acts as one of the biggest inputs of data driven smart agriculture, and sometimes people call it a digital agriculture also, right? And the use of new and advanced technology to enhance a smarter and a more sustainable fruit production. Because in upcoming days there are many governments or many in worldwide people are bothered about the food security, and this is one of the aspects that worldwide is there is a worry for that one. What about the food security? Okay, so see, all these are depends largely on the availability of reliable and external data, and that can translate to a better decision making throughout different stages of the cultivation. And with a growing population and dwelling cultivable and so-called land resources, because it's degrading as of now. And these are the two main challenges facing food production in the future, obviously. So it is the intelligent intelligence were derived from these sources that will guide the cultivation and harvesting a decision by providing a cultivators with the right information at the right time. That is what the aim of this the present technology, which looking for towards remote sensing towards the agriculture in the worldwide. So, but again, there are many people who have been talking about the remote sensing is priceless to the agribusiness, which not in India, but in other countries it is something like that actually. So to answer this question, then there are certain things that comes in picture. Knowing what to plant and determine the right to harvest, that's the one of the point comes into with respect to this question to answer. So with the remote sensing, farmers have access to complete information about idea or ideal environment and whether a condition will into the future and helping them to plan their cultivation cycle better, the prediction nature for a smart farming technology. One of the projects what I was doing, this is almost 5 years back, that project was for the Australia, where the farmers, of course it is Australian farming is concerned, where we have a labor is cheap, but the other side labor is very costly over there. So but they use a lot of machineries over there. But again, even though they use a lot of tools and technology, but still there are the common question comes in picture, that the common question or common query to a farmer is that one, what I want to cultivate, or if I want to cultivate so and so, is it possible for me? That's a common question, and the answer to be given to that one. So wherein we have talking about without knowing a farmer's land, how do you come to know? Not only farmers land, when I look for farmers land, I have to look for the other surrounding also. But apart from other surrounding, I have to look for the climatic conditions. Not only climatic, but also I have to look for the macro and microclimatic also, right? So when I look into all such kind of things, that how do I get it? So I have to go with from a district level, from a taluka to district level to the to the block level, and then going to the parcel level, and then going to that particular plot actually, right? So then, and all these are now possible, even in India also, people are talking about government also, this government is talking about the soil card also. That means the government knows that one, this is your land, and this is what the soil parameters, or the soil the quality that you have, and you can do these things are there. So that's what the comes in question, that if you know what to plant and determining the right time to harvest, then it will be for easier for the farming community to look into that one. Of course, that was again for the developed country to now looking for a developing country. Again, the other point comes, though I'm not changing slides right now, but I'm just talking about something on that. So the other point comes in picture, that accessing crop health across stages and an accurate yield prediction. This is also another important point that comes in the mind. So in this case, again, remote sensing will help in closely monitoring the crop health of a given field on a continuous basis, so as to identify any potential threats and take the correction action before they can cause any damage. And it also, can serve as a reliable method of estimating the yield output from the cultivation cycle and identify the right time to harvest based upon the weather conditions over there. So one thing, now when I talk about such kind of things, the one thing comes in the picture over there, right? Nowadays, in fact, government also encouraging the so-called the crop health insurance over there. But in other countries also, that the insurance plays a big, business over there. Right now here, see who are the stakeholders. One side farmer, another government, other agencies, and the other party is called the insurer, right? Now, so even though whatever you try to put insurance, people also like looking into that one. What is the real situation over there? Government wants to know also what is the real situation over there. So for a larger area, it is not possible just for watching and just taking photographs. No, you require a better imagery or maybe a remote sensing point of view. It is required. So assessing a crop health across stages is again another important factor that comes in the when we are talking about this also. Then when I talk about just few minutes back, I was talking about a soil card, right? So soil mapping and forecasting irrigation needs also nowadays it become reality. So because it is soil mapping is also an important factor in estimating the soil health and moisture data in a given plot of a land. Of course, it can also help identify the ideal crop and its variety to cultivate in the region, and the level of moisture it would require throughout the different stages of the growth. So as a result of this, it also helps in planning the irrigation needs as well as the advances based upon the weather forecast also. So these are the, when we answering this question, then these are the some of the things that comes in mind. So and another point that I can say that was that keeping a virtual eye on the farm, right? I cannot see, but someone can see it remotely, isn't it? I cannot take every time picture or video or something that one, but someone else, right? From a distance, it is saying. That's what I'm talking about remote sensing. So a significant advantage of remote sensing is that it always growers to keep a constant visual on their farms, no matter where they are located, and this makes sense for a big agribusiness that have farms located in different parts of the country and requires the produce from all farms to be in a certain quality, right? So such kind of things that comes into picture over there. So now I'm just answering some of the parts of the question, right? So when we talk about a crop yield analysis, we talk about a smart data, we talk about a soil erosion, we talk about a variability rate of the fertility, because this is also degrading all the time. And of course, now with the drone things are coming over there. So we talk about more on, instead of a satellite imaging, now we are talking about a drone imaging, because satellite imaging is a costly affair. And of course, it is giving a larger picture. But we want a macro climatic. Then of course, we can have a drone imaging. That could be the almost equivalent to the satellite imaging over there. So such kind of things that you see in this picture that I'm talking about. Now let me talk about Indian scenario. What exactly talking about? When I look for an Indian scenario, you have a total area is something like this, and of course, we look for a potential biological production. We look for a net sown area, obviously, because what area we have, but how much actually we have talking about it. And summer irrigation, if you talk about irrigated areas, is all quite very much less over there. Degradation is almost 50% of something was going on, right? And drought prone areas are something. So this is the scenario, but as of now, when we talk about India is concerned, and we require, and on the other side, we look for a food security. So then there is a something it has to be done to be on a need basis, and it requires something else. So see, the so many issues comes in picture of over there, like large number of marginal farmers we have, right? And increment climatic conditions, that mean uncertain in crop yield and livelihoods are coming over there. And rainfall agriculture, mostly 70% of the farmers are only on the monsoon. When something happens here and there, then obviously everybody worry about that one. We talk about that. And of course, another point, though even the technological advances are happening, but still there is inadequate agricultural extension service are there. Okay. And again, when I talk about remote sensing, the spatial and non-spatial data these are insufficient as of now. Though it is there available in government agencies, right? But it is not reaching in a right way to the end user. So this is what the insufficient agrometer environmental rural data information, that is what not reaching to the right time and right place over there. So these are the issues and in agriculture over there. So let me move on. So what we require is something like a maximum, that's called the optimum or sustainable point of view, and we require a minimum use of technology or maybe IC technologies. That is what, how can we do this one? This is what the need of the hour over there. So, but again, the thrust areas that we are talking about is something like that. We require a diversification of agriculture, we require intercropping, we require a micromanagement, we require a water management, organic farming, and these are the things we talk about nowadays. These are the thrust areas to meet the challenges of the Indian agriculture concern over there. So we have to look into technology on field or technology off the field also. We talk about that ones. But again, the common question that just a few minutes back I was trying to say, the farmers needs to know what to grow. It is not that when farmers are not knowing yields, but again, with respect to technological advances, with respect to demand, and with respect to the so-called the quick earnings. So that is what people are looking for: what to grow, when to grow, how to grow. All these questions comes in over there, apart from other business point of views are. So farmers who understand the market trend and market opportunity have a better chance of succeeding those who do not. Okay, so that is what the point people are talking about that. But however, how this can be helpful with a remote sensing or GIS point of view, that we can also look into that one, right? So again, again, when I look for, there are so many points that I have come across, but we have to look into that, the government policy and notices regarding agriculture that can uses of fertilizer, disease or preventive, cultivative measures, all such kind of things comes in the picture over there. But at the same time, also we require an education on the what need to be done at the pre-harvest stage or a post-harvest stage to ensure productivity and quality and minimum losses. This is another things that one has to know also there. So we require an advice on crop rotation to maintain the soil quality. We also require advice on the fruit and vegetables, which are, because they are more perishable in the nature, obviously. And we require also the crops are not only this the crop like rice, wheat, or maize, but the crop something else could. So we have to look for a vegetable and other things are there also we talk about. But the other thing that we talk about is that one time of sowing or area of growing a particular crop and preventive measures from the disease, pesticide use, which is again a menace of so-called, right? Again, and the different measures to be adapted also. All these are pointing to our agricultural needs over there, and that's where we may talk about the remote sensing and GIS over there. So again, there are other challenges that comes into a lot of challenges in fact over there, whereas we will talk about more on the integration of your GeoICT and sensing and networks that we talk about, right? GeoICT means, that means we talk about a location-based information communication system or a sensing system, and that can be integrated and which can give you a better picture over there. Okay, so let me go a little bit something differently. So that's what we have to integrate both the remote sensing and GIS, and where it can give you actually a good result here. So some of the things that we talk about when we talk about agriculture, so we look for in case of remote sensing and GIS, we talk about something like a crop acreage estimation, crop modeling for a yield, or maybe production of a forecast, and or maybe crop monitoring. We're talking about that one. So by using these kind of technologies, one can use for the time levelability of the crop, maybe statistics for a different decision making to a different kind of a planning could be there, or could be a crop growth monitoring, or such kind of things could be there also, right? So let me go a little bit differently, because when we talk about the agriculture, then we cannot ignore the land use and land cover also, because this is also the very primary thing before going for the other kind of things are there. So your one is to monitor the dynamic changes also, right? Because everything is, again, look for the land use and land cover. So that's what one is to understand the things are there and right. Okay. So moving ahead, now when I talk about the remote sensing part of view, like of course there are many agencies. I'm not talking much on that. Many agencies nowadays using remote sensing, point of view, both government and non-government agencies there has been used, because it now become available to the end user also. That's what the reason behind it. However, now there's something I want to say a little bit more deeply, something like what causes the plant stress. Example, factors affecting the crop spectral signature. Now, when I talk about a spectral signature, it has to take it differently over there, right? So when the fungi attacks comes over there, what is the nutrition deficiency, right? So it is just, though by looking to the a plant, one can also see, but how do you quantify it? How to quantify in a larger area, not just a one fielder. So hence you need a different kind of things are there, right? So for example, if you suppose I'm just giving a simple example over there. So when we talk about when you have, so that one you have a less amount of water in your body and you look differently, isn't it, right? Similarly, when the certain when the crop also needs a water and not having water, whatever the quantity is required at that particular time, so it looks differently, right? So from that one you can say that it could be water stress, yeah, something other stress, but how do you know that what it is a water stress or other kind of stress, right? So by looking, you cannot, though you can know, but how do you quantify it? So then you require a different kind of a technology, and that's what we talk about, these kind of things over there. So can we see the stress symptoms from the remote sensing? Yes, obviously we can see that one, right? So different color combinations has been used to find out the stressed plants over there, and also can be water estimation can be estimating water content from the remote sensing can be carried out. and you can monitor irrigation, and combining both disease and also combating both disease and pests also can be possible through remote sensing over there, right? So when I talk about the yield estimation, though I will take one case study for that one, but before that one, just I'm giving you something over there. So we can estimate how much the crop will produce, because not only you and me, of course, but again in a larger sense, the government, yeah, anybody, also the higher agencies, they looks into that one when they look at the crops over there, and they can estimate from the I mean pre-harvest stage of concern, right? So can we really know how much crop a field will produce, right? So so that's what the questions comes in the early stage of the crop over there, right? So again, estimating a crop yield using only remote sensing data or something else, right? But only it is the only remote sensing data may not be sufficient enough, because when I look into the other parameters, a micro level or macro level, then and to make it if it is a larger sense, then it's a sufficient number. But if you just looking for a village level, all things are there, then you require a different kind of things over there. But however, remote sensing can able to give you a crop yield, because there are so many mathematical models are available nowadays. Of course all the models are crop specific over there, but however these things are nowadays possible over there. So but again, when we combine this the GIS as well as remote sensing, then both can give you a better result over there, right? Or sometimes you can use a so-called example, a spot analysis you can use for making these things over there, how things are happening over there. Now the other thing like that we were using also like that, how do you identify the crops? So it has been advised that though in India or even in many places we talk about only a single crop, but however it is advisable that one people can use a multiple crops wherever possibles are there. That means intercropping over there. We talk about that one, right? Means this means growing the parallelly multiple crops over there. If that is the case, then how do you identify it from a larger area is concerned over there? So it's just a simple photography may not sufficient. That's what we have to look for a remote sensing. So hence we can use some kind of cadastral mapping, and for which we talk about that one. That means we of course we cadastral maps obviously are usually in a vector format, and this form can be used in the of course your GIS system along with the other types of data, maybe the crop types or cultivator, etc. can be carried out, right? So so a vector layer over a true color satellite image showing a different fields can be carried out, and that can be useful for this thing for the case are concerned. So why do we need to identify crops? Again, because different crops needs a different kind of a treatments and different kind of a its data. Hence, for a larger sense, and we require to identify these kind of things remotely. Okay. So again, when I talk about, of course, the question that how can we identify crop types with the remote sensing of this is the common question people comes in the mind over there, right? So so here you can look into different kind of a the color combinations. So to find out the because each crop or each leaf, if you talk about leaf area index or something like that, then it will take you different level of data and different level of game together. So from that one can find out that how can we identify different crops even in the same field over there. So you can create you can use the remote sensing techniques over there to do such kind of things over there. There is something like a small kind of work that I had done long back over there. That's I'm talking about a mobile QC over there, wherein this is a quite old work, but still it is very interesting. That's what I would like to show over here. So here, of course, this is this was actually many of you must have known also. If not, also that I'm trying to say that one. This is a mobile-based agro advisory, but it is also linking with your GIS and remote sensing. Mostly on the GIS, then the remote sensing a little less. So here, with a pinpointing to a particular field, right, for a particular farmer, because ultimately farmer has a query. Farmer is not supposed to provide a enormous amount of data. No, farmer has a simple query, and it is the agency or it is the government to know that to convey that one what he needs over there. So in that cases, I had a simple one thing that I'm trying to say, one simple questions over there. Yeah, something like that. Okay. So 1 minute before that, I can show you something. Yes. So here just a farmer has sent a picture with a geotag so called. Okay, so here this is just a graph we're talking about, right? Farmer has a picture with a geotag, right? And the farmer wants that one, why this my grapes are something like this. Okay, right? So the system now has to show that one with respect to again a pinpointing to the map, right? And pinpointing to his field. Of course, if he should be a registered farmer for so and so field is concerned. And from that one, because with the help of remote sensing and GIS, and one can able to know that one. Of course, it requires the immediate answer is not there, but still, again, such kind of advice can be, can be given to be in a different languages over there. So again, I'm coming back to the point what I was trying to say here, because when I say that one, these different maps over there, the maps are nowadays integrated to a mobile over there. And these maps gives you a when you click it, you expand it, you can find out the details of the structure or the what the properties or the characteristics of your soil or field. That is what going to come over there. I'm just showing you the glimpse over it, but this is that's what I'm trying to say over here. So that so this a bit of not only village but also a almost a village level work can be also extracted. As I said that one to a parcel of particular field also can be carried out. I'm trying to say that one. So so different one more thing I want to say also here, something like this way. So here something like, even though not only for this but also say that one for a particular field, or so how much pesticide has been used or how many weedicide has been used, these also can be calculated with respect to the GIS and remote sensing. That's what the, of course, this you can, when all this click information and you can get this information something. These are the pilot project, obviously I'm talking about. This is not across the India, but some of the things has been calculated and given or fed to the system over there. So one particular thing also what I'm trying to say that one, is something like this. This one farmer is trying to say that one two potatoes is talking about why is my potato is cracking, whereas my neighbor field, again all these are should be a geotagged image, so that when you talk about a geotagged image over there, then you can pinpoint to a particular field, and then from that one it can be analyzed that what is there not there in the field, and that can be given to you. Of course, you cannot get back again the same thing, but next time when you do this one, this can be taken. So hence the question something like this, they say like the original language that can be given the advice to the farmer. So I'm talking about so in India also, these are the Indian things that we have been using right now, right? So means like with the help of this kind of both remote sensing AGS and now going to the mobile level. So this also possible, and people are now different agencies are now trying to push these kind of things over there, so that the end users can get benefit of these kind of things over there. Now moving to the question like how does the precision mapping empower a agribusiness, how to compile agriculture maps for a unique needs, that was the question comes in picture over there. There are a lot of questions that which comes in picture, but however certain things are the answer to this question is so called the location based services, right? So nowadays whenever we talk about everything, we talk about nowadays a location based. So hence now whenever we talk about location based, then again the GIS comes in picture over there, which can capture your structure, analyze any kind of a massive spatial data set, and you can you can get an actionable inside pictures of your business and customer. This is what nowadays the big farms are using, something like ICTE and Reliance and all these are nowadays talking about this kind of things are the location based services they're talking about. I'm talking about all these are agro business point of view, but this is what happening nowadays. Okay, so what is actually in these cases apart from this, what people are talking about that they are combining both the remote sensing again with the ground truth with respect to the so-called the analytics and in an IoT based system. Not only this also, but I'm talking about also the indoor and outdoor vertical farming. So this is what the overall pictures I'm trying to say that one, that the people are now moving to the farm management and from the aerial imaging analysis they do it now. The one such thing this picture is mostly from the left hand side middle picture I'm talking about. These are from the Australia point of view, where the more on the the mechanized farms are there, where I have to because with the help of a drone imaging, this has been carried out, and with a drone imaging, we talk about the the actual picture of your thing instead of a remote sensing images over there. But again, all these are a micro level and sometimes a macro level people are talking about, because the fields are very large enough there. Not like India, we have a very fields are very small. Our agriculture fields are, but their fields are very large in the of 10 acres or more in that. So hence it is not possible with a manual things. And mechanized things are very much required over there. But again, the quick estimation and quick analytics is need of our, hence again a mechanized things over there. So hence the people have talked about the the robotic process automation when we talk about. So such kind of automation has been talked about. So when from a tractor you monitor those kind of the observation from the field, and hence with a mathematical model running behind the scene. Of course, is a cloud based again, and that can give you information that what is happening in this a particular page, or maybe overall page or something like that way. So that kind of works are nowadays going on over there. Moving ahead, so technology, when you talk about because nowadays people are talking about more on a bit of precision farming, because we want that one with a with a customized way we want to grow our products, like so hence people talk about on the more on the automatic section control. They talk about the variable rate technology, right? They talk about precision maps over there. They talk about yield maps. These are people are talking about. They are talking about the yield monitor. Also talk about you take a picture, right? And then from a couple of pictures, how do you monitor? How do you say that one yield is going to come over there, right? Soil sampling, right? And chlorophyll or a green sensors people are coming up talking about nowadays also, right? Apart from your satellite or imagery point of view, but again, with a GPS guided system, so how do you achieve such kind of things were there? And that's what talking about technologies adapted from a precision farming, which is now growing, more on the, which is taken from the agricultural economics are concerned. At the same time also, this is again from a global marketing point of view. When I talk about the people are talking about the more on the high precision positioning systems they're talking about now. Again, all these I'm talking about agriculture point of view. Okay, all these are maybe developing to a developed country over there. And again, without geomapping, things are not possible, right? When I say that when you send a picture from a field, then it's when the moment when you talk about a geotag picture, then it's pinpointing that field, and hence it's easy for carrying any kind of analysis, whether it's a soil properties, whether it's any kind of a soil nutrient from the farming. So all these are possible nowadays over there, right? So right, so hence these are the we talk about, right? And again, there is something like people are talking about the connected farming. That is the synergy of technologies people are talking about, right? So okay. So you are talking about tracking your farm conditions by visualizing the ground data collected by a sensor from a different sensors. You talk about, there are two kind of sensors when you talk about a proximity sensor and remote sensor. Proximity sensors are mostly on IoT based, whereas the remote sensing is more on imagery or satellite imagery or drone imaging based. So when both of things coming together, then it gives a real picture of that. Actually, it gives a better picture. I mean, the better accuracy is concerned about. That's what we talk about. The how do you track? You track. It's not only a proximity but also a remotely you track it. Remote means doesn't mean that only just a few distance. No, remote is mostly on the imagery is concerned over there, right? So again, so when while we talk about such kind of things, then we have to use for a soil zone maps. We have to use a GIS or GPS maps could be there. So there are a lot of technologies people are talking about. If we talk about, of course, Python is one of the the as of now people are using more on the Python. But again, you have a ArcGIS, you have a QGIS, FME, and PostGIS. All these same PostgreSQL or GeoServer. Leaflet. These are some of the GIS technologies people are using for to tracking to getting the quantifying the things over there. And there is something like when we talk about the comparing this satellite and a drone imagery, people are now moving from a satellite to drone imagery. Reason being that one, knowing exact weather condition and a prediction natural disaster with the IoT and AI technologies. That is what helping the agri business. That's what we talk about when I talk about a machine learning. When you talk about the AI based, agro business, then people are shifting from a satellite imagery to a drone imagery because they look for a precision farmings are concerned over there, right? So that is what the point, the comparison comes in picture over there nowadays. So so when we talk about the agriculture, right, then there are certain common things that one is to look into that one: the rainfall, temperature, wind, air pressure, and humidity. These are the common things that has been used. All things other apart from the soil is concerned over there. Right. So now people are moving from as I said, that one, a typical application of agriculture, weather forecasting people are using, but weather is very, very much important. Without that, even though it is becoming erratic nowadays also, but still this plays an important role. If we know a little bit ahead of things, though certain things is not under control, but still you can quantify what is going to happen over there. So for that, and I have something like this. There is something like I have one tool. Of course, before that tool, I would like to say something like yeah. So people are nowadays using the more on the CNN or the neural networks over there, right? So how things are happening nowadays. I'm talking about what people are. Of course, there is one case study what I like to show also there. So you have a map. That's what the GIS map, or maybe a plane map could be there. Then you have a remote sensing data. You combine this one. Then you have you use a so-called the convolutional or CNN, that's called the convolutional neural network, and then that's where the basic so-called the crop yield map is coming over. I'm talking about a crop yield map, right? So this is one simple idea what I'm trying to say people are using over there, and how the predictions are happening. This is what the simple way the predictions are this is I'm talking about simplest way, but there are a lot of things happening over behind the scene. So use of GIS is basically to analyzing the land, visualizing the field data on a map, and putting those data to work, right? Again, when I talk about GIS, and when you talk about precision farming, which definitely looks into the informed decisions and actions, so which farmers can get the most out of the the things. That's what I talk about. So when I talk about the crop yield prediction or the crop health monitoring and all the things when I talk about, and the ground level, and people talk about GIS and this one. So there is a tool that I was part of this one when we developed. That's called the Agri VI. So wherein we talk about of course, this is a dashboard. What I'm trying to say now here, right? So we talk about a different kind of, say, the product which example, and just a few things I'm talking about: wheat and corn and barley. I'm talking about, right? So this in a dashboard, and what is the season, and what is the so-called the yield happening, and how the income are coming over there, and those things are now as a tool that can be calculated. Of course, this is a specific to a particular farm, not necessarily for an entire thing, but again, this can be customized. So behind the scene, again, all this talking about a GIS based information system has been used to look into such kind of things over there. Now when I talk about the role of the GIS, then obviously look for the productivity, efficiency, serving and assessment of talking about this one, right? So let me take into a small case study for that one. So that I will talk about that. Let me go to a case study. Just let me change this one. 1 minute. 1 minute. I'm just. I'm going to show a case study. Let me talk about another slide. Yeah, 1 minute. So this case study is mostly on the some part of the Andhra Pradesh, Telangana, and the other parts is called the our Odisha one district I'm talking about, where we talk about a more on the crop yield estimation, and that I want to show. 1 minute. I'm just, the slide linking was not there, but again I will look into that. Okay. So this is what I was trying to say, the assimilation of remote sensing data into a crop growth model for particular for the yield estimation, and that I want to show. And let me, okay, yeah, I'm getting that one. 1 minute. So one minute, I'm just sharing now. 1 minute. Is the slide visible to you now?
Not yet, sir. Yes,
Yeah.
it is
So
visible.
So what I mean to say that one, how this assimilation of remote sensing data into the crop growth model for a yield estimation, that is what I would like to show. Just a few glimpses of this I want to show now. So if I talk about the area where we are talking about, this is this from the India point of view I'm talking about. Though I have done some other work, but I'm just showing from India's point of view here. And so this one, when I say this thing is why it is required actually, right? So basically let me took into a look. So crop yield estimation is important to inform the logistic management, such as the prescription of nutrient inputs, or maybe financing, maybe storage, maybe transport, or maybe marketing, as well as to inform the crop insurance appraisals due to the loss incurred by the abiotic or maybe biotic stress point of view. So here, what we have used this is a method to access, to yield at the village level, which is less than 5 kilometers squares of Vedli, using a remote sensing technology and a crop modeling in the so-called the Telangana, Andhra Pradesh, as well as Odisha state over there. So three things you will find over there. So here the remote sensing products where we are using the Sentinel-2 and the Landsat 8 time series data, and they calibrated with the data collected from the farmer's field. And we also derived a map showing the spatial variation in the crop extent, maybe crop growth stages, and the leaf area index, that's called LAI, and which are crucial in the yield assessment concern. So crop classification was performed on your Sentinel-2 time series data using a spectral matching techniques, and that in short form it's called SMT. And the crop management information collected from the field survey along with the ground data, obviously, and the location of the crop cutting experiments was identified based upon a crop extent maps, obviously. And of course, there is something called we also use a technique called the SAVI, that's called a soil adjusted vegetation index. And this were I mean, these equations were mostly using the Landsat 8 time series data, and we also use a technique of a so-called the reparametration of the crop simulation models based upon the several iteration using a remote sensing leaf area index. And the data assimilation approach which helps in the fine tuning the initial parameters of the crop growth model and improving a simulation with help of a remotely sensed observation, right? And though I'm not going to show a lot of mathematical models behind this, but again, this also given almost not at 100% accuracy, but to some extent, if I talk about a R square, then it may be something like maybe a 0.7 to 0.8 range it was talking about. But however, these were by assimilating the remote sensing data into a crop model, this could be you can predict the harvest, what is going to come. That was the this was the work actually in the almost last work was almost 1920. I mean, sorry, 2020. We talk about that one. That at the time this work has been carried out over there, as mostly 2 years back. This work was there. So now, when you talk about the the areas, what I'm trying to say, these are the district has been covered over there, right? So what exactly we were talking about the data set? When I talk about these are the things we have been using, right? So now when I talk about the data, when I talk about the as I said, that one Sentinel-2 and Landsat 8 data for crop type classification and LAI estimates, leaf area index LAI means, right? And these Landsat tiles were downloaded from you can download from the USGS, that means the US Geological Survey, which is a global and land cover facility website. You can get it data for 1920 rainy season and June to October. And Sentinel-2 satellite data were downloaded from the European Space Agencies, that's called ESA, and that is Copernicus open access hubs over there. And whereas so Landsat 30 minute and 16-day cloud free imagery, and Sentinel-2 also almost 10 minutes and 12-day processed satellite image were also downloaded from the cloud computing, it's called the Google Earth engine. That's right, for the rainy almost 2019 to 20. And here the multispectral data from the Sentinel-2 satellite constellation, which is a part of the European Copernicus program, and were used in this work. And this also comprises a set of two satellites, Sentinel-2A and 2B, and that provide a high resolution data and with a high combined revisit time of 5 days at the equator for monitoring and a land surface and a condition. That's what I'm talking about a data set, particularly for the satellite imagery is concerned. But the certain thing that one has to know that when the Sentinel-2 satellite provides a high spatial resolution, maybe the optical band at 10 meters, and which is that image over a large swath over 290 kilometers could be there, and which is of a high spatial resolution, and which use an optical band at 10 meters and provide a data in a optical as well near, of course, near infrared and a short wave infrared region of the electromagnetic spectrum is concerned. Now, when I talk about the because one has to know when I talk about the data and these kind of things, one has to know. That's the reason I was trying to say that. And of course, when I talk about the ground data for the crop classification, so ground data for crop classification were collected during the again a 1920 rainy season, from that is August to October, for almost 725 samples data points covering about almost 5,000 kilometers of road travel in the selected district over there. And a stratified systematic sample design was adapted to select a location by considering a cropland and a road network, right? So that data were collected almost 3 to 5 kilometers right way. So this is what when we talk about, because the ground data samples were acquired within a large homogeneous area of a particular land use and land cover. That's what I'm talking about. One is to understand the land use, land cover, right? Right. So the ground data were collected based upon a preliminary crop classification and a near real-time satellite imagery. That's what we talk about a Sentinel-2 fast color composite with a tracking a GPS using image processing software, obviously. So the ground data were collected in a 30 cross 30 meter plot and included in the locations where your LULC, that means the land user, land cover, categories, crop type, crop pattern, method of irrigation, farmer interviews wherever possible we have taken also there, and crop name as well as location data were also collected at the point to validate the crop type classification. This is what we talk about the ground data for a crop classifications are concerned over there. So but of course, when we talk about the crop cutting experiment, that's called a CCE for the yield verification. When we talk about, so in this analysis, we assisted the government for the government of India in identify the potential location of to conduct the crop cutting experiments in the Krishna as well as Anandapur as well as the Kurnool district in Andhra Pradesh, and the Puri district in the Odisha, obviously, and a Mahabubnagar district in Telangana to test the methodology over there. And the crop type also, map, obviously, we talk about, which is overlaid with the soil map and was identified to a crop cutting experiments were concerned. Of course, we have talked about a GPS location date of sowing and irrigated versus a rainfed, and other crop management details were also collected at the location. So this is what I'm talking about, the data and what kind of things we are using, because one has to understand this kind of thing when we are talking about because when we talk about agricultural thing, these are the very complex things were there also. Again, when we talk about the Landsat 8 or LAI data processing, when I talk about, see, LAI means leaf area index, and the soil adjusted vegetation index, that's called as SAVI, were calculated, right? And this is using with the Landsat 8 time series surface reflection data, and who's are available, and you can look into that one. So I'm not looking into mathematical equation, but these are there are a lot of mathematics over there. Now, when I talk about this kind of thing, then we have a, this is, I'm talking about the what you are seeing is a location of a ground data sample points for a crop classification and validation that we talk about here over there, right? So now there are certain things when I talk about the soil data and soil data, weather data, as well as the methods and approaches that one is to understand all such. I'm just quickly I'm trying to say that one. So soil data that you talk about for each CC location and used to parameterize the biophysical crop simulation models were obtained from a set up a soil profile data available from the International Crop Research Institute for the Semi-Arid Tropic, that's called ICRISAT, which is from the data repository. We have talked about that. And we have talked also the National Bureau of Soil Survey and Land Use Planning databases. So these are the soil data from where we have taken, and soil properties like such as like hydraulic conductivity, bulk density, and soil texture were also extracted from these soil profile data repositories. And additional parameters such as the drained upper limit, lower limit, and the saturation limit were also estimated based upon the soil texture using using the generic soil database available in your DSAT model, using a pedo transfer functions over there. And we also use certain parameters such as a soil fertility factor, and that is in the soil for as a free available, and meaningly that they could be modified as required when, right? Weather data, you know of this, right? And the methodologies when you talk about mainly the weather data, crop management data, and remote sensing products. So that's called the crop classification and leaf area index. So these are the things that has been used over there. When you look for a crop types and maps, and the methodology for mapping the rainy cropping pattern using a Sentinel-2 time series, and the ground data was taken from the repository obviously. So crop type classification starts with the time series data, which is a composition and ideal spectral generation, and a class identification based upon a spectral matching techniques could be there also. So the ideal spectra profiles of each crop class were generated using the Sentinel-2 normalized difference vegetation index, that's called NDVI, and temporal data. So the that's what one has to know about. So the basis for the SMT is the generation of a ideal temporal NDVI, right? And that's what is required. And the ground data used for the ideal spectral generation were collected from a homogeneous patches along with the in-depth information about the cropping system and irrigation methods. And the difference in the physiological growth stages of the different plants are reflected in a temporal NDVI profiles. Since NDVI can measure growth condition as well as the other greenness of your vegetations are concerned over there. So this is what I was talking to some of the things over there. Now, when I talk about the data assimilation approach combines remote sensing data with the growth, this is what I'm trying to say here. What you see the picture over there is something like that, where you have weather data and and soil map and all things, and soil texture, soil profile. All this we talk about which is fed to a crop growth simulation model. This is again a mathematics behind this, and this is what we are trying to make a yield estimation at a various scales over there. So when we talk about these kind of things over there, Yeah. So again, one more thing I would like to say here, when we talk about the Sentinel-2 image for the rain cropping seasons for in particular from the August to the December, when we talk about uh, the monthly maximum value composite of NDVI were computed and stacked obviously, and the time series NDVI including the maximum maximum value compositions were used to detect the phenological stages of the vegetation, and thus made it possible to identify the type of vegetation or a crop. So that is what one has to understand over there in these cases over there. So that was I was trying to say that one. Now after that you have to look for the accuracy assessment of a crop type from different maps over there, right? And then followed by your crop cutting experiment procedures could be there also, right? So this is what we talk about the optimization of your CCE sample point using a remote sensing technique that also has been used, wherein we talk about the Sentinel-2 data, climate data, and soil MP, the soil map also talk about that. We talk about the India spectrum, a spectrum, climate spectrum, and a soil spectrum. These are combined to a whole. See, all these behind this thing, there is also, as I said, that one, we have used the CNN for that one, that is to look into that, to quantify these things are there. Okay. Now, after that, what we're talking about, we have generated the so-called a cropping system model, right? So we have generated for the cropping system model for a rice, for a groundnut, I mean, of course, this is available in the distance support system for a, agrometeorology. You can find out also there. And this can be also used for your yield estimation point of view. Of course, there are other models over there you can use directly, right? And so the daily biophysical crop information, right, was generated with help of a crop growth model. And input data such as a soil condition, weather, and management data, that is the planting date, seed date, fertilizer application rate, were also prepared for each CCC location. So the most the common cultivar types representing a major part of the CCC locations were obviously used over there, and the cultivator parameters were sourced from the ICRISAT data bank and from the literature obviously we have taken. So if the required cultivator parameters were not available, then you can match with the cultivar of a similar durations. Obviously we have taken into that, right? And the nutrition supply, mainly nitrogen, was set as a free variable, and the basal application dose was matched with the planting date, and the remaining applications rates and the time were set as a free variable. So these are some of the things that has been taken into account. That's what I was trying to say a little bit in depth over there. And the optimization process start with the initial model parameterization by adjusting the free parameters so that the model simulated LI is a agreement with the Landsat 8 and the LI observation, right? So the simulated LI values depend upon the different different values of the free variable, like example planting date, nitrogen dose, or a soil profile parameters that are generated by minimizing the value of the the cost function over there. So you can look into that. Okay, so after that you will look into the so-called the spatial distribution of your crops over there. So this was something that I talked about the different the Mahbubnagar, Anantapur, Krishna, and Puri district over there. We talk about a spatial distribution of the things over there. So here, when I talk about these kind of things over there, these what you see here is the spatial distribution of different crops across the different states, district we talk about, right? So so here, just something I want to say here, the no, the yield assessment, of course, in the Anantapur district, sorghum, rice, and major crops in the Kurnool district, all things we are talking about. We were talking about these kind of things, widely spread across the chosen mandals over there, which occupy nearly 60% of the total crop areas are concerned, right? So, so this is what is giving a different kind of pictures. You can quantify all such kind of things over there. Now, when I coming to the so-called the crop yield and crop yields and limitations, That means the mean, the variance, the standard deviation, and coefficient of the variations were calculated from your crop cutting experiments collected from the crops in the respective district. However, this crop cutting experiment plot were identified using a obviously remote sensing techniques we have talked about, along with the different parameters such as the crop area, extent, proximity to the road, accessibility, right? These also has been taken into account. So the crop cutting experiments could not be conducted in the proposed location, as a farmers were sometimes unwilling to harvest the crop in their field also there. So some of the things this we also occupied such kind of thing now. Now when I talk about the this is what talking about a location of different crop cutting experiment. These are just different maps and different color combinations has been used over there, right? So that's what I'm trying to say here. And so this is like rice yields we talk about. Then we talk about the different district over there where we talk about how these were also I mean in a ground truth I'm talking about. Let me took some ground truth figure also there where we have been talking about a geotagged image where we've been talking about the Puri district of Odisha. Obviously we talk about over here, right? So so such kind of things were there. And again when we look into the comparison, so this study when you talk about this has been investigated with the potential combination of a high resolution LI data with a crop modeling to access the crop yield at a field scale. And in the approach used, the initial step involved mapping different crops using a high resolution images with a high accuracy. And these crop extent maps were, 1 minute. Battery to them. Yeah. So these crops extend maps were very useful in identifying the crop types as well as the underlying different crop conditions over there. And we also use a crop, making as a base map to identify the proposed location to perform a different kind of CCs over there. So so obviously the crop extent map enabled us to identify a crop growth stages using a NDVI decision tree algorithm and a plan that timely harvesting the crop in different CCs over there. So what you see here, the comparison of a simulated yields and observed yields of a maize and groundnut crop that you have seen over here. I mean, this is what the rice, obviously, right? This is what you see is a comparison of a rice yields and observed yields in the Puri and Krishna district over there. The other pictures that we talk about is the groundnut and maize crops over there, right? So what I mean to say in this, all these things is talking about using a cost function measuring the distance between the simulated state variables and observed ones. The method employed automatically they adjust the setup model input, and that difference between the different length 8 LI and your crop model simulated can be minimized over there. So all these what I'm trying to say in a conclude may. So with a simulation of remotely sensed satellite data, we could effectively predict the crop yield under both irrigated and rain-fed conditions at each CC locations, and the estimated yields of rice, maize, and groundnut in selected district of Andhra Pradesh, Odisha, and Telangana. We have talked about that, and this also gives us a great assimilation approach in estimating the crop yields. Obviously, we talk about. And of course, but this is not the one. A more rigorous evaluation will be necessary to investigate the model's efficiency, which is we are working on that for different climatic and atmospheric condition and other parameters, because these are only these those coastal areas we talk about mostly. But however, it is not for other areas. We have to test it right. So this study basically used to for a crop extent maps in the yield assessment by using a NDVI time series as well as exploring the SMT approach along with the ground survey data, and that's what we have been talking about this one, right? But however, when I say that one, when I say this, of course, when this our work also had the potential of a high resolution temporal images and ground data for mapping the crop land at a field scale. And mapping the crop type is the first step towards the characterizing important crop growth environment in order to understand the crop condition as well as the homogeneity. So leading to a sustainable use of a resource and improvement in the farming system, obviously. But when I talk about the upcoming work, of course, this is ongoing work as of now. Still, the models are coming up. This includes the yield estimation using a satellite data and comparing the crop yields simulated from a standalone model that we are planning as of now. So this work also published in the journal. This you can look if you look for the journal of Indian Society of Remote Sensing. You can find this work in published in the 2021, right? Okay, so this one you can find out these works. The other works are still going on over there. So now when I talk about this, let me come back to over there. So what I was trying to say is for more on the crop, the remote sensing data into crop growth model, what I show here in this case. But however, as I said that one, the remote sensing, when I talk about the other work, though I'm not talking about the work as of now because the limited time, as of now. But however, this this data, when I talk about you have to approach different agencies to get into that, and sometimes data also purchased for different agencies. Sometimes this data are freely available. But again, all these are as a game to understand the different models and all things. So that is what I want to say in this model, how this remote sensing data has been used and what kind of data we have been used for one particular work I have shown. But however, there are other works were there and which I have not shown as of now here. So that's what the one I was trying to say. Let me share my concluding screen over there. 1 minute. So 1 minute, I'm just trying to see concluding screen. So what I mean to say, the one that I want to say that when the multimodal, national or a disciplinary approach is one of the better ways to solve a few open solutions in the sustainable Indian agriculture, particularly concerned over there. And there are a lot of scope to work on these kind of things. Not only the remote sensing, but also GIS and IoT in agriculture or AI in agriculture. When I talk about, people talk about digital agriculture. There are a lot of scopes are there, right? So if anybody would like to work on, then people can approach me, and then I just sharing that screen. 1 minute, 1 minute. My contact details, you can be there. So 1 minute, yeah. So this is what you can reach to me for this kind of any kind of works over there. So regarding this the agriculture particular point of view, because I work in these areas almost more than 10 to 12 years. So technology in agriculture is my forte, and that's what different climatic conditions I have worked. So I can help you out in this. If anybody want to do research or consultancy in these areas, you can reach to me in this address. Thank you to listen to me, because however limited time, so I may not cover up so many things. But however, anything that you can approach, and I can happy to answer your queries to look into that. Thank you very much.
Thank you, sir, for enlightening us about various applications of remote sensing in agriculture field, from agro advisor to soil maps, IoT based agriculture mapping, and farm management. Thank you once again, sir. Thank you. Dear participants, the attendance link is posted in Google Classroom. So please fill the attendance form. Thank you once again, all of you.
Thank you, Amir sir. Sir, I would like to have one question related
Yes.
to if we are having the advanced farming
Yes.
suggestions to specifically the Vidarbha region
Yeah.
farmers, because now, as you said, that it is for the farmers those who have the larger land.
Yes.
So if we
Yes.
are talking about the small farmer land and we
Yes.
need to
Yes.
help them out in the
Mm,
rural
mm,
areas, what would be
yes.
the cost included in the complete farm mapping and advising solution?
See, all these what I have shown you. All these are mostly the funded projects are from the government of India. Yeah,
Yeah.
other agencies over there, right? So
Mm.
though I have worked for commercially, but things over there, but that those are the again those are the large scale farmers, not as small scale farmers over there, or whatever as far my experience is concerned, right? So I will suggest that one. So as a small farmer, these are as of now this are still as a not as scarcity, but this is more on the cost point of view is concerned over there,
Mm.
right? However, what these are we talk about more on the satellite and all this, but however, these
Mm.
things can be now possible through a drone imaging, right? Which I have not
Okay.
shown here, but people can hire drone, and nowadays people are talking about drone imaging to calculate the NDVI and all such kind of things are there in a village level, not as a one
Mm.
individual farmer, a group of farmers or a village level farmers. They can look into that. So a cost of maybe if I talk about hiring a drone and analytics, all things are there. Maybe if I, of course, I have to look for a open source things over there instead of a proprietary one. One should use open source technology over there. Then it may cost maybe 30 to 50,000. Within that, and one can be possible over there. That's what I want to say right at this moment. But however, what I have told you here is a more on the large farmers, small farmers. But I am
Mm.
also working with the small, not in the Vidarbha. I'm working in the Marathon region as of now. For the drought, vulnerability, I'm assessing again through remote sensing and GIS. I'm talking about that one. So maybe by end of this year, I could finish it. Then the small level I can able to say at this moment I cannot say, but again after maybe a couple of months I will to say. There are two things I'm working as in the Marathon regions over there. Also one is from the disease, cultivation, agricultural disease point of view, right? Pest and disease.
Yeah. Yes.
The other one is the drought vulnerability. These are working. Maybe after 1 year, I will able to of course publish also and able to open this kind of things over there, right? But all these are gradually these things are now government is pushing also. Government also pushing like a soil health card. Similarly, government also trying to push over there. But time will say how soon they are pushing, right? So that the small scale farmers can get benefit of it. But these are wait a little bit patience. But government is putting some schemes over there. Yes.
Okay. And if we want to go for the leaf disease analysis, so which
Yes.
kind of data we need to use? Satellite data.
See, I took a DAPNA. I talk about a Sentinel-2 data I have
Yeah.
used. So these are sufficient enough to look into that.
Sufficient. Okay,
Yes.
fine.
Yes. So these are so, I mean what the experiment I shown. I have used Sentinel-2. All things are there. So these are easily available and you can work with that one. It is sufficient enough for any kind of work. Yeah.
Okay, thank you so much. Dear participants, please, your question forum is open, so you can ask the questions to the expert.
I will hand over the slides, whatever I've shown to you, to you all, so that you can get, because mine is open, nothing wrong. There is, I have pushed all the slides so that you can get a benefit out of it. Okay.
Okay, okay. Thank you so much,
Thank you, sir.
sir,
Thank
for
you, sir.
sparing the time
Yes.
and enlightening us.
Thank you.
Thank you.
Thank you so much, sir.
Thank you. So I'm leaving now.
Yeah.
Okay, sir.
Thank you. Dear participants, please fill the attendance form before leaving the meet. This is today's attendance.